finding the greatest common factor. So what does it mean when we say greatest common factor or GCF? So GCF refers to the largest divisor of the given numbers, meaning to say we're going to find the biggest number that can divide the numbers. And in finding the GCF, we have three methods. The first method is listing method. So how are we going to do this? We're going to list down the factors of the given numbers. For example, let's find the GCF of 8 and 12. So what are the factors of 8? So we're going to list all the numbers multiplied together will be equal to 8. And we're going to have 1, 2, 4, 8. 1 times 8 and 2 times 4 is equal to 8. Another number is 12. Finding its factors, we're going to have 1, 2, 3, 4, 6, and 12. 1 times 12, 2 times 6, and 3 times 4 are all equal to 12. What are the common factors? So we have 1, 2, and 4. Among these factors, the largest is 4, meaning to say the GCF of 8 and 12 is 4. Another example, 24 and 36. So let's list the factors of 24. We have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Those pairs of numbers have the product which is 24. Next, 36. We have 1 times 36, 2, 18, 3 times 12, 4 times 9, and 6 times 6. As you can notice, I wrote the factor once only. So let's have the common factors. We have 1, 2, 3, 4, 6, and 12. Among the common factors, the biggest is 12. Therefore, the GCF of 24 and 36 is 12. Let's have 9 and 16 this time. The factors of 9 are 1, 9, and 3. So 1 times 9 and 3 times 3. For 16, we have 1 times 16 and 4 times itself, which is 4. And the only common factor that we have here is 1. Therefore, 1 is the GCF of 9 and 16. Let's have the second method, which is the prime factorization. So how do we do the prime factorization method? In this method, we're going to use only the prime factors of the given numbers. Again, let's have 8 and 12. So let's get first the prime factors of 8. So we have 2 times 4. And 2 is already a prime number. 4 is not yet a prime, so we need to factor it out. And the factors of 4 are 2 times 2. And again, 2 is a prime number. Let's factor 12. The product of 2 and 6 is 12. And 2 is already a prime number. Let's get the prime factors of 6. So we have 2 and 3. So writing all the prime factors of 8, we have 2 times 2 times 2. While the prime factors of 12, we have 2 times 2 times 3. As you can see, I align all the common factors. So I didn't write 3 under the factor 2. So let's bring down the common factors. We have 2 and another 2. Getting the product of the common factors, we're going to have 4. Therefore, the GCF of 8 and 12 is 4. Same result as we had when we used the listing method a while ago. Next, let's have 18 and 24. So the factors of 18 are 2 and 9. Again, 2 is a prime number. Let's try factoring 9, and we're going to have 3 times 3. And 3 is already prime number. Next, 24. Factors are 2 and 12. So let's encircle the prime number, which is 2. Then let's factor 12. And that is 2 times 6. Again, let's encircle the prime number, which is 2. And the prime factors of 6 are 2 and 3. Both prime numbers. So again, listing down the prime factors of 18, we have 2 times 3 times another 3. While 24 has the following prime factors: 2 times 2 times 2 times 3. And again, let's bring down the common factors. We have 2 and 3. Getting the product of these prime factors, we have 6. Therefore, the GCF of 18 and 24 is 6. Now, let's have the last method, which is the continuous division. So how do we do this method? So let's divide them by 2. 8 divided by 2 is equal to 4. And 12 divided by 2 is 6. You can notice that we can divide both 4 and 6 by, very good, by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. So 2 and 3 don't have a common divisor. Multiplying them together, it is equal to 4. So the GCF of 8 and 12 is equal to 4. So as we use the listing, the prime factorization, and this continuous division, the result is still 4. Let's have another example, 18 and 24. So let's divide both 18 and 24 by 2. 18 divided by 2 is 9. 24 divided by 2 is 12. And we can still divide 9 and 12. By what number? Correct. We can divide them by 3. So 9 divided by 3 is equal to 3. And 12 divided by 3 is equal to 4. The product of 2 and 3 is 6. Therefore, the GCF of 18 and 24 is 6. Finding the least common multiple. So again, there are 3 ways in finding the LCM. The first one is by listing method. In having the listing method, we are going to write or list down the multiples of the given numbers. For example, 6 and 8. So the multiples of 6 are 6, 12, 18, 24, and so on. Meaning to say, there are still multiple of 6 greater than 24. The next number is 8. The multiples of 8 are 8, 16, and 24. And as you can see, the least or the smallest multiple they have is 24. Therefore, the least common multiple of 6 and 8 is 24. Next, 12 and 18. Let's have the multiples of 12. They are 12, 24, 36, 48, and so on. The next number is 18. The multiples of 18 are 18, 36, 54, and so on. Now, the first multiple they have, or the smallest multiple they have, is 36. Thus, the LCM of 12 and 18 is 36. Next example, 4 and 20. So I have here 4, 8, 12, 16, 20, and 24 as the multiples of 4. For 20, we have 20, 40, 60, and so on. As you can see, the first common multiple they have is 20. Therefore, the least common multiple of 4 and 20 is 20. The next method in finding the LCM is what we call prime factorization. So again, we're going to list all the prime factors of the given numbers. So let's have again 6 and 8. Getting the prime factors of 6, we're going to have 2 and 3. Again, 2 and 3 are already prime numbers. While in 8, factoring 8, we're going to have 2 times 4. 2 is already a prime number. So we still need to factor 4. And we're going to have 2 times 2. So writing down the factors of 6, we have 2 times 3, while 8 is 2 times 2 times 2. So unlike in finding the greatest common factor, wherein we're going to bring down only the common factor, using the prime factorization in getting the LCM, we're going to bring down all the factors they have, including the common factors. So we're going to bring down the 2, 3, 2, and the other 2. So multiply them together, you're going to have 24. Again, how it became 24? 2 times 3 is 6. 6 times 2 is 12. And 12 times 2 is equal to 24. Again, the LCM of 6 and 8 is 24. Let's have another example. We're going to use prime factorization. So let's have 12 and 18. Factoring 12, we're going to have 2 times 6. So 2 is already a prime number. We still need to factor 6. So it is 2 times 3. And those numbers are prime. Let's proceed with 18. So we're going to have 2 times 9. Factoring 9, we're going to have 3 times 3. So they are all prime numbers. Let's write the factors of 12 and 18. So for 12, we have 2 times 2 times 3. How to check whether your prime factors are correct? You multiply. Then the answer should be the given number. For example, 2 times 2 times 3. And that is equal to 12. For 18, we have 2 times 3 times 3. Bringing down all the factors they have, we're going to have 2 times 2, which is 4. 4 times 3 is equal to 12. And 12 times 3 is 36. Therefore, the least common multiple of 12 and 18 is 36. So let's have the last method in finding the LCM, which is the continuous division method. So we're going to have again the same example, which is 6 and 8. Now, to find the LCM using this method, we need to divide both numbers by a common divisor. And that is, 2. So the quotient of 6 and 2 is 3, while the quotient of 8 and 2 is 4. You can notice that we cannot divide 3 and 4 by a number aside from 1. So we're going to list all these numbers including the common divisor and the quotient. So we're going to have 2 times 3 is 6 times 4 which is equal to 24. Therefore, whether you use the listing method, the prime factorization method, or this continuous division method, you're going to obtain the same LCM, which is 24. Now, let's have 12 and 18. Dividing 12 and 18 by a common divisor, the common divisor that we're going to use is 2. So 12 divided by 2 is 6. 18 divided by 2 is 9. Divide again the numbers by a common divisor, and that is 3. 6 divided by 3 is 2. 9 divided by 3 is 3. We're going to list again those numbers. We have 2 times 3 is 6. Times 2 is 12. Times 3 is 36. Thus, the least common multiple of 12 and 18 is 36.